Good morning, students. So today I am going to deal with next topic in analytical geometry, that is three-dimensional geometry. So before that we are discussing about straight lines, slope of straight lines and different form of equations of straight lines and so on. So next very important and easiest topic, that is three-dimensional geometry. In this topic, total marks 1 mark 1 question, 2 mark 1 question and 5 mark 1 question, totally 8 marks in this topic. Okay. Now 5 mark it is selected question. Okay. Now here, what is the meaning of three-dimensional geometry? Short form 3D. Look here. Now if we take a straight line, now we have to find out only its length. So ಇದರಲ್ಲಿ ನಾವು ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು, ಲೆಂತ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಓನ್ಲಿ ಫೈಂಡ್ ಔಟ್ ದ ಲೆಂತ್, ಸೊ ದಟ್ ದಿಸ್ ಈಸ್ ನೋನ್ ಆಸ್ ಒನ್ ಡೈಮೆನ್ಷನಲ್ ಬಿಕಾಸ್ ವಿ ಗಾಟ್ ಓನ್ಲಿ ಲೆಂತ್. ಇಫ್ ಯು ಟೇಕ್ ಎ ರೆಕ್ಟ್ಯಾಂಗಲ್ ಆರ್ ಸ್ಕ್ವೇರ್, ರೆಕ್ಟ್ಯಾಂಗಲ್ ತಗೊಂಡಾಗ ವಿ ಹ್ಯಾವ್ ಟೂ ಡೈಮೆನ್ಷನಲ್ಸ್, ನೇಮ್ಲಿ ಲೆಂತ್ ಆ್ಯಂಡ್ ಬ್ರೆಡ್ತ್. ವಿ ಗಾಟ್ ಟೂ ವ್ಯಾಲ್ಯೂಸ್. ಸೊ ದಿಸ್ ಈಸ್ ನೋನ್ ಆಸ್ ಟೂ ಡೈಮೆನ್ಷನಲ್ ಜಾಮೆಟ್ರಿ. ಓಕೆ. Whereas if you take a cube ತಗೊಂಡಾಗ, so we have three values, namely length, then height, then breadth. So we have three values, length, breadth and height. So this is known as three-dimensional geometry. 3D means three axes, x-axis, y-axis, z-axis. Two-dimensional means only two axes, namely x and y axis. Okay. Remember, if you take a straight line, we have only to find out length itself, so that is known as one dimensional. If you take a rectangle or square, we have two dimensions, namely length and breadth. If you take a cube ತಗೊಂಡಾಗ we got three values, namely length, breadth and height. So this is known as three-dimensional geometry. Okay. Now here consider three axes, namely x-axis, y-axis and z-axis. These three axes meet at a point origin O. Now clearly these three axes are mutually perpendicular to each other. As you know that if you take two axes, x-axis and y-axis, observe it. Clearly these two axes are perpendicular to each other. Like that, in three-dimensional geometry, x-axis, y-axis, z-axis, all these three axes are mutually perpendicular to each other. It means x-axis is perpendicular to y-axis, y-axis is perpendicular to z-axis and z-axis is perpendicular to x-axis. Now like this, these three axes are mutually perpendicular to each other like this. ಈ ಥರ ಬರುತ್ತೆ. ಸೊ ಹಿಯರ್ ದಿಸ್ ಈಸ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್, ವೈ ಆಕ್ಸಿಸ್, ಝೆಡ್ ಆಕ್ಸಿಸ್. ಆಲ್ ದೀಸ್ ತ್ರೀ ಆಕ್ಸಿಸ್ ಆರ್ mutually perpendicular to each other. X axis is perpendicular to y axis, y axis is perpendicular to z axis and z axis is perpendicular to x axis. Remember, these three axes are mutually perpendicular to each other. Now here in two axes, these two axes are perpendicular to each other, whereas three axes are mutually perpendicular to each other. Now here the x axis and y axis determine that part. This part is known as xy plane. E part ಗೆ ಏನಂತಾರ, xy plane. The x axis and y axis determine this part. That part is known as xy plane. Y axis and z axis determine this part. This part is known as yz plane. And similarly, x axis and z axis determine this part. This part is known as xz plane. Remember, the x axis and y axis determine this part, that is known as xy plane. Y axis and z axis determine this part, that is known as yz plane, whereas x axis and z axis determine this part, that is known as zx plane. Okay. Suppose if you take a point P, suppose the point P lies on xy plane. ಒಂದು ವೇಳೆ P ಪಾಯಿಂಟ್ xy ಪ್ಲೇನ್ದೊಳಗೆ ಇತ್ತು ಅಂದ್ರೆ What is the coordinates of point P? The P coordinate ಏನು ಬರುತ್ತೆ? The point P lies on xy plane, no z axis, so that coordinates of point P is x, y, 0, because z coordinate is 0, because that point P lies on xy plane. Suppose the point P lies on yz plane, then x coordinate is 0, so coordinates of point P 0, y, z. Whereas suppose the point P lies on xz plane, which coordinate is 0, y coordinate becomes 0, that is x, 0, z. Remember, the x axis and y axis determine this part, that is known as xy plane. Y axis and z axis determine that part, that is known as yz plane, and z axis and x axis determine this part, that is known as xz plane. Suppose the point P lies on xy plane, then coordinates of point P are x, y, 0. Whereas suppose the point P lies on yz plane, a point yz plane ಒಳಗಿತ್ತು ಅಂದ್ರೆ x ವ್ಯಾಲ್ಯೂ ಇಲ್ಲ, yz plane ಒಳಗೆ ಇರೋದ್ರಿಂದ x coordinate is 0, y, z. Suppose the point P lies on xz plane, there is no y axis, so that coordinates of point P x, 0, z. Remember. Okay. Now, here in a two-dimensional geometry, x-axis and y-axis perpendicular to each other, whereas the x-axis and y-axis are perpendicular. These two axes are divided into how many parts? 4 parts. First part, second part, third part, fourth part. Okay. The x-axis and y-axis divided into how many parts? 4 parts. First quadrant, second quadrant, third quadrant, fourth quadrant. As you know that in first quadrant, OX and OY both are positive direction of x and y axis. So first quadrant, the ordinates are positive, positive, plus, plus. Whereas in second quadrant lies in OX dash and OY. OX dash lies in negative direction of y axis, that is minus. OY lies on positive direction of x axis, that is plus. Second quadrant is minus, plus. Whereas in third quadrant, OX dash lies on negative direction of x axis, OY dash lies on negative direction of y axis, both are negative direction, so that coordinates are minus, minus. Whereas in fourth quadrant, OX lies on positive direction of x axis, OY dash lies on negative direction of y axis, so coordinates are plus, minus. So you know, so remember, these two axes divided into how many parts? 4 parts, namely first quadrant, second quadrant, third quadrant, fourth quadrant. In first quadrant, both the values are positive sign. Second quadrant, x coordinate is negative, y coordinate is positive. Third quadrant, both x and y coordinate is negative. And fourth quadrant, x coordinate is positive, y coordinate is negative. So positive, positive, negative, positive, negative, negative, positive, negative. Only in 2D. 2 axes divided into 4 parts. Whereas 3 axes divided into how many parts? 8 parts. Not 6 parts, that is 8 parts. That is known as octants. These 3 axes divided into 8 parts, that is known as octants. Now the sign of the octants are, how to write? Now leave it this one, take 2 axes, in 2 axes divided into 4 parts. Now what are the quadrants? First one is positive, positive, second one is negative, positive, third one is negative, negative, fourth one is positive, negative. Whereas these 3 axes divided into 8 parts, that is known as octants. The sign of the octants are, how to write? Write first 4 terms as it is, again same copy it, write again same 4 components, minus, plus, minus, minus, plus, minus. In first 4 are positive sign, another 4 are negative sign. It will get 8 octants. This is first octant, second octant, third octant, fourth octant, fifth octant, sixth octant, seventh octant, and 8th octant. How to write? ಹೇಗೆ ಬರ್ಕೋಬೇಕಿದನ? 2 axes divided into 4 parts ಗೊತ್ತಿದೆ ನಿಮಗೆ. What are the 4 parts? Positive, positive, negative, positive, negative, negative, positive, negative. ಇವೇ 4 ಮತ್ತೆ ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳೋಣ. Positive, positive, negative, positive, negative, negative, positive, negative. First 4 write positive sign, another 4 are negative sign, it will become 8 octants. First octant, second octant, third, fourth, fifth, sixth, seventh, eighth. In first octant, x-axis, y-axis, z-axis all are positive. In second octant, x-axis is negative, y-axis positive, z-axis positive. Third octant, x-axis negative, y-axis negative, z-axis positive. Like that, totally 8 octants. They may be asked in CET question, suppose the point P, say -3, 1, 5, lies in which octant? Leave it numbers, only observe sign. Sign ಅಷ್ಟೇ observe ಮಾಡಿ. ಮೊದಲೇದೇನಿದೆ ಮೈನಸ್, ಸೆಕೆಂಡ್ ಒನ್ ಪ್ಲಸ್, ಥರ್ಡ್ ಒನ್ ಪ್ಲಸ್, ಮೈನಸ್ ಪ್ಲಸ್ ಪ್ಲಸ್, ಎಲ್ಲಿದೆ ನೋಡಿ ಮೈನಸ್ ಪ್ಲಸ್ ಪ್ಲಸ್, lies in which octant? Second octant. Suppose the point -1, 3, -5 lies in which octant? Or leave it numbers, observe the sign, negative sign, positive sign, negative sign, negative, positive, negative, ಎಲ್ಲಿ ಬರುತ್ತೆ ನೋಡಿ negative, positive, negative, lies in which octant? Sixth octant. Okay students, so remember these three axes are divided into 8 octants. The sign of the octants are positive, 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 negative, positive, positive, third octant negative, negative, positive, fourth octant positive, negative, positive, fifth octant positive, positive, negative, sixth octant negative, positive, negative, seventh octant all are negative sign, eighth octant positive, negative, negative. Remember, ಇದನ್ನ ಹೇಗೆ ಬರ್ಕೋಬೇಕು 8 octants? As you know that in 2 axes divided into 4 parts. ಆ 4 parts ನಿಮಗೆ ಗೊತ್ತಿದೆ, positive, 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 then negative, positive, then negative, negative, then positive, negative. ಇವು 4 ಬರ್ಕೋಬೇಕು. ಇವೇ 4ಅನ್ನು ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳಿ, minus, minus, plus, minus. Okay, then first 4 are positive sign, another 4 are negative sign. This is the sign of the octants. Remember, they will ask CET question, ಒಂದು ಪಾಯಿಂಟ್ ಕೊಟ್ಬಿಟ್ಟು lies in which octant, ನೀವೇನು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು, ಸೈನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಈಗಿದೇನೆ ತೊಗೊಳ್ಳಿ, -3, 1, 5, ಮೈನಸ್ ಸೈನ್, ಪ್ಲಸ್ ಸೈನ್, ಪ್ಲಸ್, ಇದು ಮೈನಸ್ ಇದೆ, ಇದು ಪ್ಲಸ್ ಇದೆ, ಪ್ಲಸ್ ಇದೆ, ಮೈನಸ್ ಪ್ಲಸ್ ಪ್ಲಸ್, lies in which octant? Second octant. Suppose the point -1, 3, -5 lies in which octant? Minus sign, plus sign, minus sign. ಎಲ್ಲಿದೆ ನೋಡ್ರಿ, minus, plus, minus, minus, plus, minus, lies in which octant? Sixth octant. Clear students? Okay, so remember these 3 axes are divided into 8 octants, 8 parts, that is known as octants. Okay, the sign of the octants are, these are the sign of the octants. Okay, next result, most important result, that is distance formula. Distance formula. As you know, the distance between 2 points in 2D, that is A is a point x1, y1, B be a point x2, y2, then distance between 2 points, you know the formula, already learned in 10th standard. Distance AB is equal to x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Same concept in 3-dimensional geometry. Now here the question, derive the or find the distance between 2 points. 2 points, say x1, y1, z1 and x2, y2, z2. Here this is in 3D. Okay. Now to find the distance between 2 points, they will be asked, very important 5-mark question in your question paper, part D question. So how to solve? Look here. Let x, y, z 3 axes, x axis, y axis, z axis, O is the origin. Okay. Now here take 2 points. Let A is a point x1, y1, z1. B be a point x2, y2, z2. Be 2 points. Join AB. Now the question to find the distance AB using geometrically. How to solve it? Construct from the point A, draw AL and BM perpendicular to which plane? XY plane. AL and BM perpendicular to XY plane, join LM. Okay. Now, L is a point lies on which plane? Only XY plane. No Z-axis value. So, coordinates of L are X1, Y1, no Z-axis, that is Z coordinate is 0. Similarly, M point lies on again which plane? Same plane, XY plane, no Z-axis value. Again, coordinates of point M is X2, Y2, no Z-axis, that is 0. Therefore, L is a point X1, Y1 and M be a point X2, Y2. We got only two values. Therefore, LM is equal to, in earlier classes you know the formula, LM is equal to distance between these 2 points under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay. Now we got LM. Then again construct from the point A, draw AN perpendicular to BM. Draw AN perpendicular to BM. Okay. Now, AL lies on which axis? AL lies on which axis? Z axis. What is AL length at the point A? Z axis value is Z1. So, AL is equal to Z1. Similarly, BM lies on which axis? Again Z axis. Then BL length is which one? That is Z2 because BM lies on Z axis. So that BM length is Z axis value Z2. Then to find AN is same as LM. AN is same as AN length is nothing but LM length. But you know the value of LM. What is that? Under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. We got AN. Similarly, to find BN from the figure, BN is equal to, how to calculate? BN length can be written as BM minus NM. BM length alle NM length less maadi. So, how to write? BM minus NM. Right? That is BM minus NM is same as, NM is parallel to what? AL. NM is same as AL. So that BN is equal to BM length Z2, AL length Z1. We got BN value. We got BN and AN value. Now clearly from the triangle ANB, angle N is 90 degree. It is right angle triangle. Right. Therefore, by using Pythagoras theorem, AB square is equal to AN square plus BN square. Correct? Substituting the value. What is AN? AN is same as LM, that is equal to under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Its square. Root cancel. X2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus Bn square. Bn value z2 minus z1. Its square, that is z2 minus z1 whole power 2. This is the value of AB square, side AB square. Therefore, AB is equal to, taking the square root on both sides, the distance AB is equal to under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. This is known as distance formula. Same formula, now when 10th study ಮಾಡಿದ್ರಲ್ಲ ನೀವು ಅದೇ formula ಅಲ್ಲಿ 2-dimensional geometry ಇತ್ತು, only 2 values. In 3-dimensional geometry, one more term. So remember, distance between 2 points is given by the formula under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. This is known as distance formula. That is most important. Practice it. I will repeat once again. Now the question, derive the distance between 2 points, say x1, y1, z1 and x2, y2, z2. Now how to solve? Consider 3 axes, x, y, z axis. O is the origin. Take 2 points. A is the point x1, y1, z1. B be a point x2, y2, z2. Join AB. Now to find the distance AB. Then construct from these 2 points, draw AL and BM perpendicular to which plane? XY plane. Again from the point A, draw AN perpendicular to BM. Since the point L lies on which plane? XY plane. Therefore, what is coordinates of point L? X1, Y1, no Z axis value, that is Z value is 0. Similarly, M point XY plane, coordinates of point M. X2, Y2, no Z axis value, that is 0. Therefore, L is the point x1, y1, M be a point x2, y2. Then LM is equal to, using distance formula in 2D, under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay, now we got LM. Now, to find AN. Now, AN is perpendicular to BM. Okay, now AN is same as LM. AN length ಮತ್ತು LM length same ಇದೆ ತಾನೆ? So that is AN is equal to LM, but you know the value of LM, under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay. Then to find BN. Now BN can be written as, this length can be written as BM minus NM. BM length alle NM length less madidre, it will get BN. Isn't it? So BN is equal to BM minus NM. That is BM minus NM length is same as AL. That is BM minus AL. So therefore BN is equal to, BM length is BM lies on which axis? Z axis. So BM length is Z2. BM length is Z2 minus A length is Z1. BM length is Z2, then A length is Z1. Now from the triangle ANB, angle N 90 degree, apply Pythagoras theorem. By using Pythagoras theorem, AB square is equal to AN square plus BN square. AN value is, and that is under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2, its square, root cancel, plus Bn value z2 minus z1, its square, z2 minus z1 to the power of 2. This is the value of AB square. Taking the square root on both sides, therefore AB is equal to under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. This is known as distance formula. In 10th standard dalli ನಾವು 2 axis ಅಲ್ಲಿ solve ಮಾಡಿದವಲ್ಲ, distance between 2 points x1 y1 x2 y2 is given by the formula under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Whereas in 3 axis, one more term, the distance between 2 points x1 y1 z1 and x2 y2 z2 is given by the formula under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. This is known as distance formula. Clear, students? Oh. So based on the distance between 2 points x1 y1 z1 x2 y2 z2 is given by the formula, remember, under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. Based on that formula, to solve the problem, one more question. Now here the question, find the distance between the following pair of points. First one, A is a point 235, B be a point 431. Now here you call it as a x1 y1 z1 and here x2 y2 z2. Okay, now to find the distance between 2 points, you know the formula, that is AB is equal to under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. Substituting the value under root of x2 minus x1, What is x2 value? 4 minus x1 value 2 to the power of 2. What is y2? 3 minus y1 is also 3 to the power of 2 plus z2 value 1 minus z1 is 5 to the power of 2. Then simplify root of 4 minus 2, 2 square 4, 3 minus 3, 0 square is 0, 1 minus 5 minus 4 square is plus 16, 16 plus 4, 20. That is root of 20 can be written as, we can write 4 into 5, that is square root of 4 is 2 into root 5. So distance between 2 points value 2 root 5. Okay. Similarly, second one, same method. A is the point minus 3, 7, 2. B be a point 2, 4, minus 1. Call it as say x1, y1, z1 and here x2, y2, z2. Then distance between 2 points formula, AB is equal to under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. That is root of x2 minus x1. x2 is 2 minus x1 is minus 3 minus into minus plus 3 to the power of 2. Correct? y2 4 minus y1 is 7 to the power of 2 plus z2 value minus 1 minus z1 is 2 to the power of 2. Simplify root of 2 plus 3 5 square 25, 4 minus 7 minus 3 square plus 9 minus 1 minus 2 minus 3 square plus 9. Totally how much? Root of 25 plus 9, 34. 34 plus 9, that is 43. Correct? Root 43. Right? Whereas one more problem, third one. A is a point 2, minus 1, 3 and B be a point minus 2, 1, 3. Call it as x1, y1, z1, x2, y2, z2. Then distance between 2 points AB is equal to under root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. Substituting the value, root of, what is x2? x2 value is minus 2 minus x1 is 2 to the power of 2 plus y2 value 1 minus y1 is minus 1, that minus into minus plus 1 to the power of 2. z2 value 3 minus z1 is 3 to the power of 2. Then further simplify root of minus 2 minus 4 square is plus 16, 1 plus 1 2 square plus 4, 3 minus 3 0 square is 0, that is root 16 plus 4 20, that is 20 can be written as, we can write 4 into 5, but square root of 4 is 2 into root 5. These are the distance between 2 points. Each problem carries 1 mark. They may be asked in final exam. Okay students?